My name is Jack Young, and I am a project manager at CIRIA. So thank you for joining us for today's webinar on managing unexploded ordnance in marine environments. Before we begin, I would like to just cover a few housekeeping points. Today's webinar is being recorded. Attendees are in listen-only mode. If you do have any problems with connection or audio, please just raise your hand and one of the CIRIA team will be there to help you out. There will be plenty of time for questions during the webinar. Simply type your questions into the Q&A box and state if you wish to direct your question to a particular speaker. We will monitor questions as they come in, but what you can do as audience members is click the thumbs up button to like other attendees' questions. It just helps us to pick out the most popular questions. Please also do share resources in chat, and also we will be doing some audience polls, so more on that later. We encourage you to share your views and experiences with us through Twitter or LinkedIn using the handles and hashtags shown at the bottom of the presentation slides. We do aim to be finished at 11:45. So yeah, we'll see how that goes. Brilliant. So really what brings us together today, unexploded ordnance, or better known as UXO, deployed in the marine environment during military activities or dumped at sea, can pose a major threat to the marine aggregate industry. Everyday activities such as trawling, dredging, or just general management of marine infrastructure may encounter UXO unexpectedly, which can have catastrophic impacts if handled incorrectly. Dealing with unexploded ordnance is not a new challenge for the European marine aggregate industry. CIRIA's guidance on the assessment and management of unexploded ordnance risk in the marine environment does go some way to give some guidance on the topic with respect to UK legislation and regulatory regimes, but the approach to safe and efficient detection varies from country to country across Europe. So with this webinar, supported by the European Marine Sand and Gravel Group, or better known as EMSAG, we'll cover the different approaches to managing UXO in marine environments across Europe. Just to give you a quick background on EMSAG, for the past 24 years, they've worked to identify the developments and information needs for the marine sand and gravel constituents concerning all aspects of the industry across Europe. Just to give you a bit of background on the program for today, Kees Laban will start with an introduction to UXO. We'll then move on to a UK perspective on UXO management before speaking about UXO management in the Netherlands. We'll then go through a state-of-the-art methods in detection and removal of UXO offshore, and then on to the German requirements for sand and gravel extraction concerning UXO. As I mentioned, there will be a Q&A session at the end, which will allow for the expert panel that we have today to answer some of your questions, which I hope do come in and get voted so we can see which ones are the more popular ones. So today I'm delighted to be joined by Kees Laban, Chair of EMSAG and Marine Geologist for the Marine Geological Advice, Adam Wheeler, the Offshore Project Manager at 6 Alpha Associates, and who are one of the co-authors of the CIRIA guidance on UXO, Luke Ahler, the UXO specialist from Rijkswaterstaat, Michael Schwartz, geophysicist or lead geophysicist at Boskalis, and Daniel Standhaft at the project manager and geologist at Kiezensand Ostsee. Apologies if I've mispronounced any of those, but I think it's okay. So let's begin the first presentation by Kees Laban, Chair of EMSAG. Kees will set the scene with an introduction to UXO. So if I could invite Kees to unmute and turn your webcam on so the audience can see you. Brilliant, and over to you.
Okay, thank you very much, Jack. Good morning, dear participants. Welcome to this Force by MSEC organized webinar. As Jack mentioned, this webinar will be focused on the management of unexploded ordnance remaining in and at seabed in the North Sea and the Baltic Sea since the World Wars. Can I have the next sheet, please? As you can see on those maps, these are the areas where the bombs came, but by tidal streams and by fishermen and so on and so on. A lot of ordnance has been removed and is in other places. Next sheet, please. Since the installation of the thousands of windmills at sea, the detection of UXO at locations of the pillars, the interconnecting cables, the cable routes to the shore, have been intensely surveyed for the occurrences of UXOs and chemical weapons. Some months ago, for instance, I read in this year along cable route in the Dutch sector, 14 UXOs were detected, showing the need of surveying along those routes. Since World War II, bottom trawling fishermen got thousands of UXOs in their nets and have been landing them in a port for detonation, or often the UXOs were thrown back into the sea. The penetration of their trawling nets is up to 7 centimeters into the seabed, so they surfaced only UXOs at and near the seabed. But a large part of the southern North Sea is covered by sand waves, reaching altitudes up to 13 meters, but mainly 4 to 6 meters. At the left map, you can see the area where the most sand waves occur. In a large part, those sand waves are mobile, and their mobility in the Dutch sector, for instance, varies along the coast from 0 in the south to more than 20 meters per year in the northern part. And in the right map, there's a brand new map. You can see in the south, in the blue, is the 0 area, and the green, and then in the red is more than the dark red in the north is more than 20 meters per year. According to the Danish Coast Agency, in the Danish sector, the mobility of sand waves is even up to 50 meters per year. By this process, UXOs, which had ended up on a sand wave more than 77 years ago, are now often underneath the sand wave or at the dense soil underneath. And they are covered by several meters of sand, or they became exposed between the two sand waves. In the top picture on the sheet, you can see the process. The UXOs on the sand wave. The sand wave is moving, and the UXO will be in the sand wave and at least underneath the sand wave, or between the two mobile sand waves, and then they are exposed again. The next sheet, please. At geological survey, I was involved in geological mapping of the Dutch sector of the North Sea, and we have been fiber coring and drilling at more than 14,000 locations without accidents caused by hitting an UXO. We never thought about the danger of hitting an UXO, although the finds of the fishermen were known to us. For research, in the center section areas in the coastal zone, yearly tens of fiber cores are carried out, commissioned by the Ministry of Public Works and Transport of the Netherlands. Last year, this ministry commissioned Marine Sampling Holland to study the impact of several types of fiber cores, CPTs, and box cores on buried mines, with wall thicknesses of 2 and 4 millimeters. In the test, the fiber cores and the other systems stopped by hitting the mine and did not penetrate the iron wall. Next sheet, please. some of the results of the heavy fiber core, which has a weight of 3,500 kilograms, is given in the left picture, and you can see in red the impact of the fiber core, but it stopped and it did not penetrate the iron. In the green, there was a light electric fiber core with a weight of about 1,500 kilograms, and did not penetrate the iron. In any case, it is reassuring that fiber cores and CPTs will not be damaged or worse by hitting an UXO. And this is a brand new investigation. We are happy to read that. So I thank you for your attention, and I wish you a fruitful webinar from here. Bye.
Brilliant. Thank you, Kees. We're now going to hear from Adam Wheeler, Offshore Projects Manager at 6 Alpha Associates. Adam will share the UK perspective on UXO management. So over to you, Adam.
Good morning, everyone. My name is Adam Wheeler, and I am the Offshore Projects Manager for 6 Alpha Associates. I'm also the member of the Institute of Explosive Engineers. I'm a former Royal Navy clearance diver. I'm qualified at an advanced level of EOD. I've actively participated, managed, and supervised numerous operations globally for the military over a 23-year period. Since retiring, I've spent the next 19 years operating and supervising large explosive remnants of war remediation projects, and both in hostile and marine environments. Today, I'm going to talk to you about 6 Alpha Associates, a residual risk, CIRIA 754, the assessment of management of UXO risk in the marine environment, the what, the why, the where, and the when, what is the UXO, and the focus of services for 6 Alpha. As you can see, 6 Alpha, as Jack mentioned earlier, we are authors, or so as I say, Simon Cook is the co-author of the CIRIA guideline. And as you can imagine, our boss, being the author of this document, he's very keen that we make sure that the I's are dotted and the T's are crossed. We have offices based in Camberley, Bury St Edmunds, and overseas offices in Germany, Spain, and Hong Kong. We have extensive experience. We've participated in over 80 offshore wind farm and cable projects globally, and 4,000 terrestrial projects, UK and Asia Pacific. We have 26 payroll employees, and the core of our experience of managing UXO comes from a military background. We have also oil and gas former employees who participate in the analysis of geophysical survey data. On the consultant side, we have historic UXO research and reporting, UXO general consultancy advice, and we provide UXO data analysis and PUXO, which is potential UXO target selection. We also obviously operate as UXO contractor oversight, and we also function now obviously with boulder analysis. We also form obviously on the contractor side, as all of the above. We also involved in land survey and land and marine UXO target investigation and disposal. The residual risk. Any UXO that is filled with high explosives must be considered potentially dangerous. You can see here an image on the right-hand side. This is a fishing vessel off the south coast of UK that trawled up a German ground mine. The clue obviously is in the picture. This shouldn't be on the surface, and bringing it to the surface was extremely dangerous. This was responded to and dealt with by the military. If it's old or been buried or submerged for a long period of time, it should not be considered safe or no longer able to function. Explosives will remain as effective and as efficient as they were when they were first made. It's just the ability to function and design may have deteriorated somewhat. High explosive content could still be highly sensitive to heat, shock, friction, and also more importantly, hydrostatic pressure release. Bringing an ordnance to the surface is the greatest effect on the ordnance. And you can see in this next picture, a fishing vessel off the east coast of UK trawled a UXO, and on the process of recovering its net, the item functioned, and the crew members on board were lucky to survive. 4 of the crew members had life changing injuries. UXO is highly dangerous and may cause significant injuries or fatalities, as listed in this report. Therefore, UXO is, if encountered, you need to know what to do, or just importantly, what not to do. Okay, so how are we going to manage explosive remnants of war? In the military, the Royal Navy, the Army, and the Air Force have teams of dedicated specialists based in strategic locations throughout the UK. They are primarily supporting the UK global military operations. However, they also can be tasked by the Joint Service Task Centre, normally in support of civil powers, which is normally instigated by the police or the Coast Guard. It's critical to understand that they adhere to a strict set of Joint Service Standard Operating Procedures, which are continually revised and supported by a Joint Service Training Academy, which trains and enables and certifies specialist operators to respond to historic and modern munitions, which are generally encountered by the public and reported by either the police or in an offshore environment, the Coast Guard. It is also critical to understand that these guys form part of a team, and the senior person within that team is usually qualified at an advanced level. One of the struggles that I have, obviously changing over to commercial operations, is there is no formal procedure for UXO management in the commercial sector. International Mine Action Standards have a draft document. However, IMAS predominantly lays out a framework for humanitarian demining and should not routinely be considered a management or a procedural document to support offshore remediation operations. CIRIA 754 offers guidance to bridge this gap between the military SOPs and commercial operations. It's merely a bridging document and is in part a way of bridging the gap between military disposal operations and what should be considered for commercial activities. So what is CIRIA 754? The document is intended to act as guidance to inform anyone operating in the marine sector who's involved with planning, construction, maintenance, or decommissioning operations, specifically conducting intrusive engineering activities in areas which may encounter unexploded ordnance. So this is the foundation framework for anyone conducting any activity offshore or intertidal areas that they believe there's going to be some invasive or intrusive activity. And I would also suggest that anyone reads this document to start the process. The guide focuses principally on managing those risks that might be generated by UXO containing high explosives, including abandoned explosive ordnance, such as sea dump munitions or abandoned ship or aircraft wrecks. It's the principal starting point, and I strongly encourage anyone who are contemplating operations offshore to read this document. The management of chemical munitions are not covered in this scope. Okay, why is the guidance required? It highlights the types of UXO threats which may be present in the marine environment, and there are many. It provides a framework assessment and management of the associated risks that might be generated by prospective or actual detonation of UXO in the marine environment. It identifies the roles and responsibilities, as well as the duties in different organizations and stakeholders under existing legislative and regulatory regimes. Critically, and this is a very important part, it provides advice to the marine sector for engaging an appropriately qualified and certified UXO specialist organization to support or provide risk mitigation services. I cannot emphasize this last point enough. There are numerous organizations that are extremely competent in managing the UXO remediation in the offshore environment, both in UK waters and in European waters. However, there are several organizations that do not quite meet that criteria. It is critical that they meet the criteria to support your operations. The consequences of not adhering to CIRIA 754. I'm sure the audience do not want to wake up on a Monday morning to this picture in their inbox. Here we see a British A Mark 12 ground mine containing in excess of 500 kilograms of explosives. As you can see, this picture illustrates the peel grab that had falsely identified the item as benign, and there's several obviously penetrations of the outer case, and the operator decided it was safe to do and bring it to the surface. If this had functioned, it would have critically damaged the system, possibly fatally killing the operator and causing significant damage to the support vessel, potentially sinking it, and also obviously causing significant injury or death to the crew on board, notwithstanding the sinking of a vessel in a significant navigable channel. So this can be the consequences of not adhering to CIRIA 754. When do we use CIRIA 754? Now, it's quite challenging to summarize a 200-page document. So what I've done, I've pulled out 4 sections, which are the foundation, I believe, to the management of safe UXO remediation in any project. First element is the UXO threat assessment. So it's identifying the potential for UXO to be present on the shoreline or in seabed from a range of potential threat sources. 6 Alpha provided desktop assessment, and I believe this is one of the most fundamental elements of any planned operation, to understand exactly the history from a UXO contamination point of view on your potential work site. Followed by, obviously, with a risk assessment. So assessing the risk using the widely accepted concepts of likelihood of the event occurring and the consequence of that event occurring, and considering the source of risk, the receptor to the risk, and the pathways through which that risk can manifest, i.e. what are you doing, what are you likely to come in contact with, will it likely function, and what is the actual consequences of that. We also do a threat and risk assessment that identifies the parameters of that threat and then advises our clients about the appropriate remediation to be taken. The UXO risk management, again, another element of this document, assessing the risk management approaches of avoiding or mitigating the risk to tolerable levels, and then sharing, transferring, or tolerating that risk, residual risk. It's not an attempt to reduce the risk to 0. It's not a requirement. 6 Alpha, from a review of the project scope, can prescribe the most efficient, effective, and safest method of remediation methodology. Finally, the UXO risk mitigation investigation identified UXO and rendering it safe in situations where it is not practical to avoid the risk. 6 Alpha can independently review and approve a target investigation procedure and, where required, a disposal activity. The next group of slides are going to give you some idea of the munitions that are likely to be encountered and the appropriate systems and methodologies that we're likely to deploy or advise to deploy. As you can see here, there's a historic pictures here of some airdrop weapons or bombs, and you can see the top left image and the bottom one, that is an SC50, and that is usually the minimum size UXO we would recommend for investigation. This is their current, their as-new state, and this is typically what they come across to us. So easily overlooked. However, some of the key features you can see here are the ballistic shape, and obviously some of the features you can see of that tail section in the top right middle there are obviously very easily identifiable to the original source. We're coming across maritime munitions. Here you can see their as-new state. We're looking here at a torpedo top left, an AS mortar in the middle, and the classic buoyant mine at the top. And this is what we get a call on a Thursday afternoon or a Friday afternoon saying, what do you think this is? All of these items do contain energetic substances, and all of them are a hazard to the construction. So that's what they were like when they were new. This is what they look like, or similar to when they've been in the water for periods in excess of 70 years. Just because they're old and rusty doesn't mean to say they do not contain any energetic substances. Probably in the aggregates industry, in a nearshore environment, this is typically what gets caught up in the dredges or in some of the hoppers. Although these items are relatively small, any one of these items can be lethal at up to ranges of in excess of 100 meters. So just because they're small, do not summarily dismiss them, or even indeed be tempted to kick them back over the side. Focus of services for 6 Alpha. We are in the land and marine sectors. We operate in UK, Europe and Asia Pacific. And as I said before, one of the critical things that we do for all of our clients is the desktop study, risk mitigation strategies, project management, contractor oversight. Sorry. Hello, I've lost control of the screen. Apologies about that. Risk mitigation strategy, project management, contractor oversight, survey design and survey specifications, critically important for any geophysical survey. We also operate as client representatives in the offshore environment, and we also use UXO data QC and analysis, anomaly grading and UXO target identification, and we can also provide independent alert certificates for any operations that we oversee. And also one of the critical points is our technical advisory notes. Our technical advisory notes, or TANs, allow us to reduce the area of avoidance depending on the level of intrusive engineering activity and the systems being deployed. We also obviously contractor services as all of the above, and in the offshore TR, target investigation and disposal, and onshore UXO survey and target investigation and disposal. So the benefits of choosing 6 Alpha: we are unrivaled in experience and qualifications and have deep vertical knowledge of the marine remediation environment. Level of competency: we have an excellent safety record, 0 LTI in 18 years, and certified ISO LMS systems. We have technical innovation, advanced data processing techniques, and UXO selection that sets us apart from other geophysical organizations. The technical advisory note is a unique service that we provide, and is always a benefit to the client to reduce the areas of avoidance of UXOs and obviously reducing the amount of survey area required. And we have safety critical calculations that we can support any organization that come across a munition, and we can reduce those areas of avoidance for other technical intrusive operations. Our brand reputation: we are UXO's risk management practitioners, difficult situations and problem solvers, extensive survey data analysis and disposal knowledge, an excellent reputation for schedule cost savings. Thank you for your attention. Do you have any questions?
Brilliant. Thank you, Adam. As Adam just mentioned, do keep your questions coming. We will pick them up in the discussion shortly. So remember also to click the thumbs up to like other attendees' questions. So yeah, over to Luke Arler. So Luke Arler is a UXO specialist at Rijkswaterstaat. Luke will talk about UXO management in the Netherlands and how they're moving to a more proportionate approach. So over to you, Luke.
Thank you, Jack, and well, welcome everyone to this webinar about UXO management in the Netherlands, and more specifically about UXO management during beach nourishment projects by Rijkswaterstaat. For those of you who don't know, Rijkswaterstaat is part of the Dutch Ministry of Infrastructure and Water Management, and we're responsible for the design, construction, maintenance, and operation of the main infrastructure in the Netherlands, including our coastal defenses, which, well, of course, is one of the most important parts of our work. I have a background in UXO consultancy for 5 years, one of the larger companies in the Netherlands, and moved towards the client side of things 3 years ago in 2019. Susan, can you move up a slide, please? Thank you. Before we go in depth, I want to, well, talk to you about the context for a bit. What kind of works are we doing at our coasts, and what is the issue at hand here? We're going to the more boring part afterwards, towards labor legislation in the Netherlands. We can't skip that. It's a large part of our work to work according to the Dutch labor legislation. We're going to talk about risk mitigation and also about the limits of that. And well, we did a UXO risk study, and yeah, that will play a role in the considerations for a safe and efficient approach towards UXO risk mitigation during our works. First of all, Susan, can you move up, because I think I have a small poll for you. Let's see, on a scale from 1 to 10, I'd like to hear from you how you would rank the safety risk of UXO during offshore labor. And 1 would be insignificant and 10 would be top priority. Let's take about half a minute for this so people can consider and put in their vote. As I cannot see how many people have voted yet, I will leave it to Susan to hand over the presentation to me when people have filled it in. All right, thank you. Well, that's quite high on the priority list. That's a good thing, most definitely. I think it's averaging to about a 8 out of 10, 9 out of 10. So that would be considered a real top priority there. Thank you for voting. That gives me good insight on how the audience is viewing this issue. All right, I can take over the presentation from here. That's a good thing, great. Well, first of all, some context, labor legislation, like I said, and well, let's move up. Well, first of all, the context in which we work here. Rijkswaterstaat is responsible for maintaining the basic coastline of the Netherlands. And the basic coastline was defined back in 1990, and it is a low water mark from that year. Of course, that does erode the coast, and with the rising sea levels, it erodes more and more. So to maintain that basic coastline, we do beach and foreshore nourishment on a large scale. We mine the sand at sea up to 12 million cubic meters per year, and we actually supplement the coast by putting the sand right on the beach or in the foreshore to give the tide a chance to supply the sand towards the shore. The demand for sand is increasing, definitely. Not only because, well, the rising sea levels make the nourishment more important, but also because the North Sea is getting fuller and fuller. We take from borrow areas, about 20 meters of water depth. And of course, those borrow areas have to compete with offshore wind farms, cable installation zones, and other aspects of marine contracting for importance. What we do is that we design these works, we calculate them, and we hire our offshore contractors, large dredging companies that usually employ trailing suction hopper dredgers to mine the sand and nourish our shores. Only since 2012 do we really actively mitigate the UXO risks. So we have a large history before that and afterwards, and we're starting to gain more and more insights on the risks and the effectiveness of mitigation, which obliges us to get a more broader view on this issue. Let's see. All right, UXO in the North Sea. Well, like Adam before me already said, naval mines, aerial bombs, there are all kinds of UXO in the North Sea. UXO Intelligence, a consultancy firm, calculated that there will be about 36,300 naval mines left in the North Sea, the Dutch part of the North Sea, from the First and Second World War. According to the Dutch Navy, there are about 10,000 aerial bombs left, mostly British bombs that were jettisoned during the Second World War. From those UXO, since 2005, about 2,000 were encountered and reported to the Dutch Royal Navy since 2005. About 1,500 of them were disposed because a lot of these UXO cannot be retrieved because the geomorphology of the North Sea, like Kees Laban already said, makes it hard to retrieve objects because sand simply flows over them and they get lost, actually. Well, the causes might not be very strange to you. Of course, naval combat and mine laying from 1914 to 1918. In the First World War, the Dutch neutrality didn't help us there. And we were the front line in the Second World War for up to 5 years between occupied Europe and the United Kingdom. The challenges we have here is the mobility. Of course, naval mines, for example, got loose from their anchors and went adrift during the war. Fishermen do bottom trawling and tend to move these objects, and the objects get buried. So we have some challenges tackling this issue. Now for the bit of the boring part, the Dutch labor legislation. We have quite an elaborate system of labor legislation in the Netherlands. And more specifically, what I'm talking about here is the working conditions degree, arbeidsomstandighedenbesluit for the few native Dutch speakers here. As a client, Rijkswaterstaat has to provide a health and safety plan to our contractors with the foreseeable risks. So what we do is we provide a risk identification and evaluation, identifying the possible risk, for example, of UXO and other issues that may be encountered. According to Article 4.4, tackling hazardous materials, we need to work according to the occupational health and safety strategy, which means that there is a hierarchy of measures. We have to start out with source measures, taking away the danger. If that's not possible due to technical, operational, or economical feasibility, we can take collective measures, separating the danger and the people in the danger zone. Individual measures, only protecting the people in harm's way, and PPE, which is of course not really applicable to the dangers of UXO. Last of all, there's a small separate article about UXO, Article 4.10 in the law, and that says that danger of UXO must be ruled out through a desktop study. Well, that's kind of hard. And if it's not possible, appropriate measures should be taken to exclude the danger. Pretty strict legislation there. The current strategy, mitigation strategy, is that on the forehand, we do a desktop study, of course, as obligated. But given the fact that the North Sea is, well, riddled with UXO, we cannot rule out the danger in any of our borough areas. So we usually, our contractors start out with source measures, taking away the danger for the largest part. We do an offshore survey, so magnetometry, EM, electromagnetic or acoustic survey, and then we avoid potential significant UXO, or the UXO that pose a danger to equipment and personnel when detonated on the sea floor. And to the right, you can see a picture of aboard a dredger. All those small red circles are objects to be avoided with the dredge head, and all the green lines are the hopper tracks. Besides that, we take collective measures. We use a bomb grid on the dredge head with a mesh of about 8 centimeters to prevent large objects like larger artillery projectiles from entering the pumps of the ship and getting, ending up on shore. The pump room is mostly off limits because, of course, there is the pump in which UXO may be caught, and the bulkheads inside the ship are closed. We still have some individual measures we can take. For example, put the employees on the bridge so that if an incident occurs, they are in the safest position of the ship to safely abandon it if necessary. All these measures lead to a really safe working environment. I think we can really say that. But right now we are seeing the limits of the avoidance strategy of avoiding these potential UXO. We're losing up to 40% of the available sand in our borough areas, and that's a lot, especially with the ever-increasing demand for sand. This leads to increasing costs. We need more borough areas, more distance to be sailed for the same amount of sand, and that in turn leads to increasing emissions, which isn't exactly helping our environmental problems. What do we see? We do avoid these objects, so we don't really get to identify them, but less than 0.5% at TENET projects of these potential UXO with the current state of art is a UXO. So we hope to see a lot more technological advancements there in the near future. Besides, we still have large and sometimes undetected UXO, even when avoiding these objects in our dredge head. On the right, you see a picture of the chamber of a contact mine. This is the high explosive maintained in the contact mine, and the amount of ferrous mass was not large enough to mark it as potential UXO, and it ended up in the dredge head. Oops, we don't want to wake up to that. Besides, what we don't take into account is that there is a significant health and safety risk at survey vessels as well, because it's offshore labor. It's not exactly, it is riskful, simple as that. So we are starting to wonder, is this measure, this avoidance strategy, proportionate to the risk posed by UXO, which is a pretty hard and complex question to ask. We commissioned a risk study by an independent research agency. And what we came up to is, well, on forehand, we must view it as a risk, and a risk is usually defined as probability multiplied by impact. We often tend to look at the effects, at the impact of a UXO detonation, but the probability is often just overlooked. The likelihood of encountering, given the large footprint of our works, is significant. We tend to simply encounter these UXO in our borough areas, period. But the likelihood of detonation, especially due to the effect of water, salt water, 75 years in a hostile environment on primary explosive, delicate mechanical parts, and of course the depletion of batteries in some UXO really decreases the likelihood of detonation there. The likelihood of fatality is mostly dictated by the robustness of the ship and the distance between the ship and personnel and the explosion. And what we found out is that we don't know any lethal incidents caused by UXO during dredging, but we don't have that many working hours during dredging that we can draw definitive conclusions on that. We do have a handful of health and safety incidents with UXO since 1970, but most of these incidents occurred involving fishing vessels, like Adam showed us in the last presentation. There's recently been an incident, and well, we know of a large incident in 2005 in the Netherlands, leading to 3 fatalities when an American aerial bomb detonated on deck of a vessel. So to put the risks in perspective, we put up a small hypothesis, saying that the risk for fishermen can be assumed as a worst case assumption for the risk for dredging personnel, given the huge likelihood of encountering. A trawler usually trawls about 40 kilometers of sea bottom. And besides, the likelihood of fatality when an incident occurs is higher because the UXO is lifted above the water. If we compare that to the general background risk of offshore labor, the risk of UXO for fishing vessels is more or less the same, because offshore labor involves, well, mostly line of fire incidents, entrapment, tripping, drowning, and hazardous materials as well, like gas canisters on deck. So we started to ask ourselves the question, in how far are we mitigating the UXO risks with doing dangerous offshore work, like survey, for example? This leads us to some considerations we would like to see a lot more from our contractors, and that we'd like to encourage during our procurement of works as well. And of course, we like a safe and efficient execution of beach nourishment and compliant to labor legislation. The considerations will be as follows. First of all, stay rational when identifying the risks. UXO may intuitively seem like the #1 top priority danger, but statistics say otherwise. There are way larger risks at hand during offshore labor. Risk is probability multiplied by effect. Well, the effects may be tremendous, severe detonation, but the chances of occurring that cannot be discarded. The mitigating measures do have an impact on our projects. We cannot deny that. We have a huge loss of sand, and if we want to keep our feet dry in the Netherlands, we do need that sand, and we must take that into the equation. Besides the increasing emissions from more shipping movements and the ever-increasing costs, well, do have an impact on the feasibility of our projects. Reducing the risk to zero is impossible. Even when doing surveys, even when taking all kinds of measures, it's an illusion to state that we can reduce all the risk from UXO to zero. Simple as that. Survey and avoidance is followable, identification and removal is as well. And last but not least, we need an integrated risk assessment. Survey has its own risks, dredging has its own risks, and we need to weigh them against the risk of UXO to get an overall picture of the risk we're taking, the risk we're mitigating, and the costs of this policy. And I'd say to be continued. In the near future, we hope to encourage our contractors to assess all risks equally and rationally, and we will try to integrate these considerations into our future contracts. So, thank you for that.
Brilliant. Thank you, Luke. Very interesting presentation on that. So please welcome our next speaker, Michael Schwartz, lead geophysicist at Boskalis. Michael will share some state-of-the-art methods in detection and removal of UXO offshore. Generally, how use of an electromagnetic induction sensor enables discrimination of buried hazardous UXO from harmless scrap items prior to commencement of dredging operations. So over to you, Michael.
Yes, thank you, Jack. So first of all, it's going to be a bit rough after Luke just told us that every survey is going to fail at some point. I'm going to tell you now that our survey will be perfect. So yeah, we'll see how that works. But yeah, I will give a short introduction on the state-of-the-art methods in the detection and the removals of UXO offshore. And as already said by Adam and also by Jack, first we need, prior to any operations, an assessment of the historic threat of an area. So for example, in a sandbar area, which are often nearshore areas, they are prone to UXO finds. They are often in or near important passages between the Baltic, the North Sea, and the Atlantic. And as we can see on the lower two pictures taken from the from the Fehmarn Belt tunnel crossing, we see that project areas, which we can see on the left-hand side picture, are often in important passages and vessel-ways for today's traffic as well. If we now go into the exemplary risk assessment of an area like that, again, the picture shows the Fehmarn Belt area. We see in desktop studies what kind of munitions, as Adam already said, can be encountered in the works we do. And as you can see on this picture, for example, during the Second World War in the area of the Fehmarn Belt tunnel, the British employed mine gardens to counter the troop movement of the Germans mainly. And we can see that altogether about 2,500 mines were deployed in the waters of the Fehmarn Belt crossing. After the Second World War, there were clearance campaigns which tried to mitigate the risk of UXO for future development. And we can see there are different priority areas. But the problem of it all is that in the end, more than 2,500 mines were laid, and in the area of the Fehmarn Belt tunnel, less than 200 were cleared after World War II. So that is less than 10%. That means we have a couple thousand of mines still in the area, plus airdrop munitions and artillery shells of unknown quantity. Because what needs to be kept in mind is, obviously, we have artillery positions on land securing the passages. We have airdrop munitions from fighter pilots, from bomb planes, from whatnot to counter the transit and the transfer of troops and equipment through those passages. So we can say altogether, we don't know how many UXO we will find. We don't know what kind of UXO we will find, but a risk assessment always helps to get a first idea of what we can expect. And we all know there will be, well, as I said, airdrop munitions or other munitions that will be relocated by trawling, by current, by sand wave movement. So we can expect lots of UXO in the area still today, which are a threat to our working environment. If we now go into the survey that Luke already talked about, we obviously have to survey multiple objects, which take time and costs money. On the left-hand side picture, you see an example of a sandbar area with identified magnetic anomalies. So if we could now discriminate between, say, a bicycle, which is not as harmful as a bomb, and a hazardous bomb, we could save time, cost, and already clear entire areas for use prior to any excavations. That means if we could get somewhere where we say it is possible to discriminate between hazardous and harmless items without investigation and without excavation of the item, that would lead to significantly reduced time, significantly reduced cost, and improved clearing of areas for use on sandbar areas. So how can we discriminate that? Or to put it easy, what makes a bomb a bomb? We have certain parameters like the magnetism, the weight and the mass, and the geometry and the wall thickness. If we look at the magnetism, both a bicycle and a bomb will give us an anomaly. This is why it was identified during the initial magnetometer survey. Whereas the bomb gives us ferromagnetism, the bicycle might also be introducing paramagnetism, but that is only minor differences, and we still see an anomaly and still see that we have to investigate the item. Looking at the weight and the mass, on the other hand, we see that bombs tend to be a lot heavier than bicycles. Even the worst bicycle won't weigh 100 kilos, hopefully. So we can say that for the weight and the mass, the bomb can be discriminated from bicycle. That obviously ties into what Adam said earlier. We have to see what the minimum threat item is. and have to put the weight to an appropriate number. But we can say usually with use of weight and mass, we can discriminate between a bomb and a bicycle. And then we have the geometry or the wall thickness of the material. And for the UXO, again, as we've seen on Adam's slides, there is a distinct geometry. It's usually a cylinder that is even kept, well, more or less a cylinder after 70 years on the seafloor. It's got a thick hull to contain all the explosives. And if we look at scrap, or in our case, bicycle, we do not have a distinct geometry and we have a very thin walled material. That means using the weight and the mass and the geometry and the wall thickness, we can discriminate between hazardous bombs, which we want to be taken outside of the area prior to any dredging operations, and small scrap, or in our case, bicycles, which might as well stay there during dredging operations, depending on the equipment used. What do we use to get to that target discrimination? We use the SubTEM, which is a multi-component electromagnetic induction sensor, and that enables us to calculate two indicative parameters, which are the so-called size of an object and the decay of the object. This is done by the SubTEM logging a response signal from the buried object in the ground for longer times and on more receiving units as commonly used EM sensors, because for now, the most commonly used system is doing an initial survey with the GEO MAC 882 magnetometer, and then using a TSS 440 for the investigation of the single items. If we now swap the 440 for the SubTEM, we get to a point where we can have these two parameters, size and decay, as objective measures of an object. The size there is a measure for the quantity of the ferrous mass. Again, we talk about how can we discriminate bicycle and bomb. The weight is one object, and the size measures this weight. So the smaller the induced mass, the lower the size of the object. The decay, on the other hand, is a measure of the extent of the object. So the second parameter that we can use to discriminate between bicycle and bomb. The thinner the object, the faster the decay. If we think about steel wire rope, for example, we'd have a very high decay because our induced magnetic signal on the steel wire rope decays very fast because it's a long piece of metal and usually quite thin, whereas on the bomb, the amplitude stays over a longer time and the decay is slow because, as you can see on the left, decay is just initial amplitude over last amplitude. And the faster the decay, the higher the number, and therefore we can discriminate, for example, between steel wire rope and a 250-pound bomb. If we now plot the size over the decay as the objective measure, we see that there are clusters. On the lower left, we see small stuff like cans, nails, and small debris, which we honestly do not care about during our surveys. On the upper left, we see short wires, random debris, so a high decay, but a very small size. That means a long object, but not a significant amount of mass. On the upper right corner, we see large steel wire ropes or anchor chains, a significant amount of metal, which cannot be discriminated from the amount of metal on a bomb, but due to geometry and shape of the object, we can still discriminate it. And then last but not least, on the lower right corner, we see large scrap or relevant objects, in this case, a submarine. And if we now look at where's our bomb and where's our bicycle in this decay over size graph, we see that our bicycle clusters more in the upper right corner, where we have still quite some mass, but a high decay, whereas our bomb clusters in the lower right corner, as we expected it to be, because it shows a high size, but a relatively low decay because of its compact and distinct shape. So where are our usual UXOs? And again, Adam has said something about minimum threat items in his talk, where we have to say what kind of items are the smallest items we're looking for. And for my talk, I took the examples of a depth charge, airdrop conditions, and a smaller item of an artillery shell. So if we look at where those items clutter, this is known from previous projects where we've used our system, identified those objects, and can say those objects usually clutter within the area of a size larger than 2 and a decay of smaller than 14. So this area of size larger, well, in the case of the artillery shell, 1.7, and a decay of smaller than 14. This is where our UXO can be found in the plot of of decay over size. That means that all the objects that are outside of this area are irrelevant objects to the UXO survey. Only the objects that are size larger than 1.7 and decay smaller than 14 are relevant objects. Looking at an exemplary data set, again from the Fehmarndal tunnel crossing, we see that non-UXO targets show a very wide range of size and decay combinations, and we can say they pretty much are spread out all over the place, from low decay to high decay, from low size to high size. If we now look at the UXO targets that we found on the projects, we see that the UXO targets show the expected range of size and decay combinations. That means that our size and decay parameters are proven right by the excavation of exactly those items. Looking at what those items were, we can see that we have a 21 centimeter high explosive projectile, so an artillery shell. We have a German depth charge, and we have a British Mk1 ground mine. That means all of these items were identified as minimum threat items, were found during our investigation or our survey, and we can say that 55% of the targets we investigated can be safe to be said be irrelevant and therefore left out from excavation, whereas only 45% of the targets had to be investigated by means of a manipulator arm of an ROV. What does that gain for us? Well, first of all, we see that we had an accurate selection of a threshold. We had UXO findings, and we had UXO findings, especially including our minimum threat items. So we found what we were set out to find, so to speak, from the 6-inch artillery shell all the way to the airdrop munitions. Still, we could discriminate 850 items from dredging. That means we only had to hover over the item, survey with our subtem, and could say just from the data, this item is not relevant. And to get to the point, what does that all mean for you or for the dredging? It means we have a very large amount of saved time. We are talking about a project that is 4 months in execution, and we can say that on the average, we save about 45 minutes per investigation of an object, which we have not do because of the discrimination. That multiplied by the 850 items we could say are irrelevant leads to a saved time of about 1 month of only investigation of UXO. So to sum up, that means by use of subtem, we could shorten the period of the project where no dredging work was done by 1 month or 20%, given that we only had to work for 4 months instead of 5 months now. And we could sooner start the actual operations of the dredging, saving time and obviously cost to the employer. If we now find a UXO, we have, or we usually at the moment still do a relocation of the UXO by airlift assemblies connected to the UXO. This is usually done in an area, for example, a natural reserve area where demolition is not allowed, like, for example, in the German Wadden Sea. So what we can do is we attach the balloon to the pontoon, and the rib locates the UXO outside of the clearance corridor or outside of the natural reserve area. Unfortunately, that leads to quite some, well, danger, because there is not so much of a controlled movement, but a movement just on a balloon underwater where currents can loosen the UXO from the balloon. So what we did was we improved the lift and shift operations of a UXO, and the main improvement is that now the UXO is relocated by use of RV. The RV places the UXO into a subsea basket, which is connected to an unmanned catamaran. this unmanned catamaran is then connected to a work vessel by a large line. So safety for personnel involved is given due to the distance between the vessel and the unmanned catamaran. And the unmanned catamaran is then taken to an area where it's safe to place the UXO on the ground again. And if we then lay down the UXO, for example, on a sandbank, we can release the casing, and the UXO in the end is left behind on a steel net fixed in position with a marker buoy attached to it. And the advantages of that improved lift and shift is that we have less impact on the environment. No in situ demolitions, for example, natural reserve areas are needed, and we have a high safety for personnel. Thank you.
Great. Thank you, Michael. We will now move on to our last, final speaker, Daniel Standhaft, project manager and geologist at Kiesen Sand Ostsee. Daniel will discuss German requirements for sand and gravel extraction concerning UXO. So over to you, Daniel.
Thank you, Jack. So, hello, everybody. Okay, that works. So today I want to talk about the UXO and the situation and requirements in the German Baltic Sea, and shed some light on the perspective of a mining company who has to deal with it with this topic concerning permission processes. So yeah, we are a company that holds mining concessions in the German Baltic Sea. So yeah, maybe that's a little bit comparable to Loop, but we are doing it on a commercial basis. Here are the topics I want to cover today. And I would like to start with showing you a map where you can see potentially, or you can see in general where UXO is found in the German Baltic Sea and the North Sea. This map includes dumping sites, contaminated areas, and potentially contaminated areas. Although signs are not for scale, and also they don't show the density of UXO that can be found there. It is assumed in total that a total of more than 1.6 million of tons of munition are still in German waters. And there are even more unknown areas from Allied forces. So if you reconsider what Michael said in the desktop study at the Fehmarn Belt Tunnel project, this wasn't even in the map before. So there are really much more places where you can find UXO. Most of this munition came from World War II, on one hand from the combats during the World War, and after the World War, Germany was required to dispose all the munition, most in the seas, like it is shown here on the right image. Yeah, that's the main source. And what we don't know is where else munition was disposed, because like in the image, maybe they never even got to the dumping sites and lost the UXO on the way to make more rounds and yeah, achieve more disposal. Since there are similar requirements in the North Sea concerning the borrow areas and the whole UXO topic, I will focus now on the Baltic Sea, because that is where we operate our business and where we know the requirements. Here's another map of the Baltic Sea of the federal state of Mecklenburg-Vorpommern. That is where we, oh, what is happening here? Okay. Yeah, that's where we have all our borrow areas in the federal state of Mecklenburg-Vorpommern. In the red hatched area, you see a summary of all known shooting areas. So also smaller artillery shootings happened here. On the map on the right side, you see the distinction between all those areas, and that there are also very historic data included. So the first known shooting that is also included in this map happened in 1871. And again, the main activities happened in World War II. A total of around 15,000 square kilometers are shown here, and they are all potentially polluted with ammunition, and again in various densities. So there's not an artillery shell at every square meter, but potentially there can be one. Those areas are categorized as areas with no concrete danger at this time. However, if a change of use is planned, such as getting a borrow area, lying an offshore cable and other things, then a possible action is required, which means normally a UXO survey and investigation and clearance. The competences in Germany are divided in the federal state of Mecklenburg-Vorpommern, the explosive ordnance discovery service of the federal state of Mecklenburg-Vorpommern is responsible for the salvage and removal of munition. That is only in the territorial waters, so up to the 12 nautical mile zone. Further, in the EEZ, the responsibility for this topic lies by the federal government of Germany. This service is MBD abbreviation in German, and the MBD is part of the police authority of the federal state. And yeah, all our borrow areas are within the 12 nautical miles, so they are the responsible authority to go to for our borrow areas. Yeah, the task like removal of UXO can be and will be assigned to third parties, so companies who then do the responsibility of the MBD. In the last years, there were some developments in the requirements. In the past, for our borrow areas, everything concerning UXO were mostly recommendations, so not a must do. Only in areas where there is a known pollution, like I have shown you in the very first map, their UXO investigations were required to do. However, after several findings of ammunition on beaches, the regulations became much stricter in the past years. On the right side, you can see a picture of ammunition that was found in 2015 on the beach of Rerik, which had to be then completely get a UXO clearance. And it is not known how that comes. Also, if it was due to beach nourishment or if it was there before, it was not known. But because there are hazards on the beaches, the regulations became more strict. And in our most recent plan approval, so the mining permission, and UXO was mandatory even if there was no known pollution. On the other hand, in old and intensively used borrow areas, which are there for decades, and UXO investigation is generally not necessary because there is such an intense excavation that if there would have been any UXO, it were already discovered. To understand the issues we are dealing with, I have here a flow chart of the process from exploration to extraction. That should be similar in other countries as well. First, you apply for an exploration permit, do a geological investigation. And if that was successful, you can apply for a mining concession, which gives you the exclusive right on the resource. If you really want to do the extraction, you have to undergo then a whole plan approval procedure where you had in a general operating plan, do a lot of environmental investigations and hand in the environmental studies as well. Then all those documents go to stakeholders, and that is the first time the the police authority is involved and give their opinion to the purpose of our business. The UXO regulations will then be stated in the plan approval. So we really just know at the end of our whole plan approval procedure what we have to do concerning UXO. So in the latest plan approval, it was obliged for us to do an UXO investigation with an ammunition removal concept, which has to be done after the approval of the main operating plan. Then UXO investigations for large ammunition has to be done with a magnetometer and side scan sonar. And if there are any suspicious objects, they have to be investigated with appropriate actions such as RV or diver, or also discrimination, as Michael told you. Then for extractions, we have further measures such as an additional hazard prevention plan, which is pretty much that what you heard from Luke, that no crew members are allowed in the pump room, and that summarizes all regulations during the dredging process to protect the crew members and the vessel too. And in addition, for coastal protection, for sand for coastal protection purposes and in public use, there are even more requirements. Of course, they have to do an UXO investigation with a magnetometer and side scan sonar up front. But then they have to have a 10 centimeter grid on suction head for UXO, which we have for other projects as well. But then the fraction above 12 millimeter is sieved on board. And the sieved fraction is then processed with a magnetic separator, which removes all ammunition and the remnants of ammunition. And then the fraction over 12 millimeters returns to the sea, but of course not the magnetic parts, only the coarse sand and gravel. That is in order to really prevent any munition come to the beaches and harm people there. So that's why the coastal protection is even more strict. Now I would like to show you one exemplary UXO investigation that was done on one of our borrow areas. That was in an area where an actual knowledge of high explosive bombs, mines, and artillery shell existed. That led to the requirement for an UXO investigation in the plan approval process. In the first step, a magnetic and side scan sonar investigation was performed. Then the results of those investigations were filtered by different parameters and then compared with side scan sonar results. And in the third step, the remaining anomalies were checked by a diver. So you see here this area in the red circle. Those are two borrow areas, but investigated were only the blue outlined area because that was the favored area to take sand from. In total, 2,295 anomalies were found. They were then filtered by the magnetic moment over 2 ampere square meters and depths in the seabed below 1 meter. That led to a remaining of 418 anomalies. Those anomalies were then checked within side scan sonar background, and the results you can see on the right side. And only it was decided to only check the anomalies in the 2 yellow areas because there the distribution density was not so high like in the red areas. And then the diver checked all 68 points. In the end, there were no findings. So extraction is now possible on those 2 yellow areas. So that is the whole way from the plan approval to the actual mining. And now we are able to use those 2 yellow areas. Sorry, last slide is summary. You can say that the vast majority of the Baltic Sea is potentially polluted with ammunition. For us as a mining company, it's always an issue that the participation of the responsible authority is only very late in the process, so you don't know how things changes and what actions are required. On the other hand, borrow areas that are used for a long time don't need an investigation. The favorite methods for the UXO investigation are magnetic and side scan sonar investigation, and then there must be a verification of those anomalies, that is by diver, RV, or discrimination, or you can cut out the with a safety distance from those points. That's how I understood it, what Rijkswaterstaat does, what Luke told us, but then you have a loss of resources in that area, so that's not always a favorite procedure. Then sand for public use has special or additional measures that need to be taken during the dredging process. And there is, in addition, also professional staff on board, which who then checks all the remnants that are collected by the magnetic separator. So they are even stricter in that for that purpose. That was my presentation. Thank you very much for your attention, and we are happy to answer your questions at the end.
Brilliant. Thank you, Daniel. This does actually bring us to our expert panel. If I could invite all of our speakers to turn on their webcams and microphones, Case, Adam, Luke, Michael, and Daniel. We have actually received some interesting questions from the audience. So if you haven't yet submitted your questions, now is the time to do so. So I'll just bring up the little question panel. Michael, from your past surveys, are objects within the size and decay limits that you mentioned during your presentation, are they typically UXOs all of the time?
No, first, thanks for the question. They are most certainly not. As I've shown in my presentation, we applied those limits to the about 1,500 items we found on the Fehmarnbelt project, and only about 700 of those were in the area of interest for us, so size larger 1.7, decay smaller 14, and of these 700, only 22 turned out to be UXO, so a very small fraction of it, but still significant enough to deem the survey successful and necessary.
Great, thank you. The next one is actually also for you, Michael. How deep below the seafloor do electromagnetic methods typically, how deep are they able to survey?
That very much depends on the object you are looking for, because as soon as you, well, let's put it that way, you always send out a standardized signal to induce currents in your object. And the larger the object that is induced, the higher the response current. And only a high response current can be detected at a range of, say, 2+ meters away from the sensors. So, for example, a 500-pound bomb would be possible to be detected at 3.5 meters standoff. So if we are saying a flying height of 50 centimeters, we are talking about a detection depth of 3 meters. But if we are talking about artillery shells, 155 millimeter, for example, we are talking about a lot smaller distances, because the lower mass of metal induces a lower response signal, and therefore we only have a detection range of about 150 or 1 meter even. And that is always depending on the noise in the environment. So in iron-rich environments, the detection range might be smaller than in non-iron-rich environments, for example. So it's tough to answer, but we say it depends on the object. Usually we aim for 2 meters clearance depth on projects, though.
Great, thank you. The next one is more of a general question for whoever wishes to answer, I suppose. Once the UXO is confirmed within investigations, I assume, what is the likely timeline to mobilize the UXO clearance team? And how long will it take to clear the UXO? And also, is there a permit process to resume works once the UXO is cleared? So whoever is happy to.
Adam, do you want to go for that?
Sure, yeah, no problem at all. Generally, a target investigation campaign is planned to follow a geophysical survey campaign. The survey campaign obviously will depend on the size and linear length of the project areas. The target investigation teams will be mobilizing and prepare to conduct the target investigation while the geophysical survey campaign is in operation, certainly on the larger tasks for linear lines and offshore wind farms. But you need to allow in a planning process, because obviously depending where these assets are, whether it's near shore or offshore. If it's offshore, you're looking obviously an offshore sport vessel, and their programs are booked for 18 months, 2 years in advance. So you need to be coordinating that in a line. But I would suggest you think about a 90-day deployment time for a target investigation campaign, which you've already coordinated with the various target investigation contractors. What was the second element of that question, please?
Is there a permit process to resuming works once the UXO is cleared?
Yeah, well, there's a permit process anyway for the whole procedure, but once the UXO obviously has been identified as a confirmed UXO, it's either removed or it's destroyed in situation, which again is part of the permit process. And on completion of that, there will be a target investigation report for every single location that's investigated, whether it be UXO or not. So something that's listed as a PUXO, until it's physically investigated by a target investigation contractor, it's either confirmed or denied. If it's confirmed, they will complete a target investigation report. There'll be a as found survey completed to start with, then followed by an as left survey. And once the as left survey, that obviously reports then the target investigation and clearance, and then to a LARP, excuse me. Sorry, phones. Yeah, so the target investigation report, and there could be 1,000 target investigation reports. They all then are compiled, and then they go in what they call the eventual ALARP certificate, and it'll give obviously the assurance to the end user that the target and threat munitions have been investigated and have been removed, and there's an actual timeline on that as well. So it's not an ever-ending ALARP certificate, because as we know, and discussed earlier on by our other colleagues here, that the munitions move. So there's a period of time once that ALARP certificate is issued. And the ALARP certificate, as people also said, doesn't reduce the risk to zero, it reduces the risk to an acceptable level. I hope that answers the question.
Thank you. Do any of the other speakers have anything to add on that for a European perspective?
Maybe just very, very briefly, as Adam said, the demolition campaign or the removal campaign is usually at the end of the survey campaign. So we as a survey company also offer the demolition, and we usually try to already line up all those permits, all those certificates prior to the survey operations, because we expect to find UXO on every project, and therefore this entire process of permitting, of the authorities aligning on the concept is already started prior to any find of a UXO on the project, usually because it takes time, as Adam mentioned.
Okay. Next question is directed to Daniel. Is there a risk of post-war Russian military testing activity in the Baltic waters? Are there any records of this, or is this another sort of unknown in the question?
Yes, thank you for the question. I'm not sure. I think it's both. So all known testing activities are shown in the map, if they are known, that I showed you, the hatched red area that summarizes all known shootings. And but I think, or I would expect that it's still a big unknown question mark behind it. which you have to then find out by an UXO investigation.
Okay, thank you. I believe this question came through during Michael's presentation. It's how do we deal with anomalies in the way of marine piles and potentially at depth, as well as what about the size or decay of large anchors? Is that taken into consideration?
That ties into what I said earlier, maybe about not every item with a decay of large, smaller than 14 and size larger than 1.7 is UXO. There are obviously areas where we will have anchors, steel bars, old oil drums, which just from the size and shape and the wall thickness and the weight resemble a UXO. And since our subterm uses shape recognition pretty much, we cannot rule out that we will have false positives. But that also is obviously owing to the fact that we put safety buffers on every kind of objective measure, like the size and decay value. So even if we say size value is 2 for the minimum threat item, we go lower than 2 to also account for partially detonated munition, to also account for pieces of munition, which obviously do not have the same weight anymore, the same size anymore, but are still dangerous. So yes, it occurs that we identify an anchor as a relevant object, but to our understanding, it's always the better way to go for more investigations, for more objects, for a safe approach where we reduce our measures or our thresholds to really gather all the items that might be UXO. Even as I already said, only 3% of them turn out to be UXO. So yes, it happens that anchors are dug up. And I think it's a good thing because it's a huge piece of metal. It's got a distinct shape. So better safe than sorry. That would be the approach we take.
Yeah, brilliant. We did have some questions come through earlier that were answered sort of live during the presentations, but there was a follow-up from one of them. I'll just quickly find it. It was on the topic of addressing the risk of UXO that could be found within old shipwrecks, and there was a follow-up question saying sort of how much research is undertaken to identify these shipwrecks found in the work areas, to then be able to assess the risk that the ship contained UXO or the surrounding area. Because if the wreck is unknown, what steps would you take to physically investigate the wreck, if at all, or would you just assume worst case that it did contain UXO? I suppose, Adam, that would be one.
Yeah, I'll make some comparisons here. If we take, for example, the SS Montgomery, which is quite a famous wreck in the mouth of the River Thames there, it's been a headache to the UXO community for as long as it's been there. It's also surveyed every year, but the critical thing is with any wreck is the desktop assessment. There's a significant database of wrecks that can be researched from open source information. If it's a military wreck, obviously we can reach into some of the archives now that have been declassified and we can find the original cargo. But again, it depends on the end state of what the project is. Our golden advice really is, if possible, avoid it. Go around, reroute it, because it will probably be cheaper to go around than to physically investigate and then obviously remove any hazardous cargo. So the critical thing, again, obviously the staff answer is desktop assessment. Desktop assessment will reveal as much information as possible, usually then followed by a threat and risk assessment. And then if the threat and risk assessment determines that there is any hazardous cargoes in there, then a geophysical survey. And then from that, the best approach and the most efficient approach will be recommended to the client.
Okay, thank you. Unless anyone has any follow-up points on that particular question. We'll move on to the next. Okay, so this one's quite an interesting question, sort of moving into the more digital future, I suppose. It's more of a general question for everyone. Is there any scope for using AI, so artificial intelligence, to identify potential UXO offshore?
Maybe I can start on that. There is the attempt to use AI on target picking, but again, what I said earlier, the AI will deal with thresholds, and those will be, well, set in stone, so to speak. So you can give the AI something it will look for, like a shape recognition, and you can give it a number which it will look for in size. But how do you deal with a partially detonated bomb, or how do you deal with a mine share which is not showing the exact thing you would expect from a mine, or from a 250-pound bomb, or from whatever? Because on our system, we kind of use AI where we have a library of known response signals from objects that we encounter in the area. For example, if we have a LMB mine, for example, as a major item in the area, we have library responses of the LMB mine to our system in terms of size, amplitude, decay, and then we can compare that library response to every single item we find. That's done automatically by AI, and then it gives you a correlation factor. But again, you would have to feed every kind of state of the LMB mine into your AI to give it a chance to really know what an LMB mine after 20 years looks like, after 30 years, with the tail fin broke off, with a dent in the upper right, lower left corner, whatever. So again, that kind of ties into that better safe than sorry approach, where for now AI is helping in the process, but not guiding the process, because it's still a thing of the subjective knowledge of experts like Adam, for example, to say that is a UXO and that is not, even though the AI said, well, that's too small for one because maybe the tail fin broke off. So it's a tough subject to use AI. I think it, as I said, it can help, but it shouldn't guide or take over the process.
Great, thank you. I suppose it's difficult when every single scenario seems to be different. It's hard to program that sort of system to pick those up. Okay, so next question is again more of a general one. What is the procedure of managing risk when laying pipelines to pump aggregates ashore? Adam?
CIRIA will obviously outline the framework, as I detailed in my presentation earlier on. But with regard to any intrusive activity, whoever's giving you the advice with regard to interacting with the seabed, one of the questions we would ask, obviously, is what are the kinetic energies and forces likely to be transmitted from your intrusive activity? Once we know that, 6 Alpha are fairly unique in that we calculate avoidance distances for that intrusive activity, whether it be the jack-up leg, whether it be anchoring, piling, trenching, cutting, jetting, and in this case, obviously, putting in a trenching or laying a pipe down. Obviously, laying a pipe down under control is fairly inobtrusive, but to give you some assurances, if we have the technical data of the kinetic energy released by that activity, we could then work out the avoidance distance from any potential UXOs. I hope that answers the question. If not, I can go into more detail if required.
That's fine, thank you. Luke, I did actually have a question for you myself. I suppose, in your opinion, what would be the most efficient mitigating measure during sand extraction, as you explained in your presentation?
Oh, good question. I'd say any measure that does not involve introducing new risk in the working environment, and especially measures that create a distance between the possible detonation and any personnel involved. But of course, that's mostly from a labor risk perspective. As we've seen in one of the questions, of course, large UXO close to marine infrastructure, energy infrastructure, that's an entirely different class of risks and with an entirely different process of assessing these risks.
Thank you. More of a general question again. Considering UXO risk globally, how much is actually moved by human activity? So, such as fishing primarily. Where this occurs, what is the advice over the need to resurvey over time for permanent marine installations? Adam?
I don't mind answering this question. I mean, Michael may have something else to add. Typically, when we complete a survey and investigation campaign, an alert certificate is issued. If, for example, this is the, we finished the survey at the end of 2022, and the construction phase doesn't finish until 2024, we'll already work out the munitions migration burial assessment on the PUXOs that are listed in the target investigation. So if you have a working corridor of, say, 40 meters either side of the center line, if we think that the construction activity isn't going to finish for another 2 years, we'll add a proportional amount of distance, avoidance distance, onto the PUXO. So something that may initially in 2022 sit on the edge of the corridor or just outside the corridor may be within the area in 2 years' time. And an independent munitions migration burial assessment will give us that expected movement of the threat spectrum munitions in that location. So there isn't always a guaranteed end date on a LARP, but if you're speaking to your technical consultants early on the process and we understand the whole scope of the project, we can build in all those factors and parameters that then give Michael and his company the width that need to be investigated in those targets, depending on your activity that you're doing.
Thank you. I had another question for Luke actually as well. How are we dealing with UXO offshore in 10 years, would you say?
It's kind of hard to predict the future, of course, but looking at the technological advances, for example, the Boskalis system, which introduces discrimination in objects, that is, of course, a great advancement. And that may lead to easier sand extraction because we have to simply avoid fewer objects. But it's entirely dependent on technological advances, scientific insights. But at least I hope that we tend to, evaluate all risks in the process in the end, from survey, from UXO, and we need to get more experience on all these risks, I think.
Michael, would you have anything to say on that, on the basis?
Yeah, maybe the same thing I've been saying over and over again. Better safe than sorry. So even if we in 10 years' time have better discrimination techniques, better techniques to predict what is the UXO, what is not a UXO, we always have that problem, what Adam showed in his presentation, of erosion of the UXO, of forces dealing with the UXO over then about 100 years, changing shape, changing size, pieces of UXO. So even in 10 years' time, there needs to be a high matter of safety involved, a high matter of risk assessment involved. And again, always the approach, if in doubt, just excavate it and deal with it and visually inspect it and be sure about it. So even in 10 years' time, the main approach to dealing with UXO is safety, I'd say.
Thank you.
Sorry, Jack, if I could just add, please. From the military background, one of the fundamental principles of explosive ordnance disposal is remote where possible. Obviously, back in my day, when I started in 79, we were very close to these munitions when we were dealing with them. Obviously, as technology advances now, that distance is getting greater and greater and greater. And innovation and obviously appropriate financing is giving us this safety distance, the standoff from actually being in physical contact with it. Obviously, in the shallows, there's usually a diver-led campaign up to around about the 15-meter contour, depending on whatever the threat is. But past the 15-meter contour, it's usually always remote with ROVs and other systems. And you may have seen, obviously, recently fully remote excavators that have got a standoff distance from the actual controller. So while the excavator is working, if it did function, there's enough safety distance and protective walls, blast protection between that, if it should function. But the key element for anyone, obviously, is listening to this seminar here today is remote where possible. You do not want to be anywhere near any of these items if they function, irrespective of how long they've been in the water.
Brilliant, thank you. So that actually brings us to the close of the Q&A session. So thanks to everyone for submitting your questions and to the panel for answering them. Just to quickly summarize today's webinar, we had an introduction to UXO, a UK perspective on UXO and discussion on the CIRIA guidance, the UXO management in the Netherlands and how they're taking a bit more of a proportionate approach moving forward. Michael then discussed some of the state-of-the-art methods in detection and removal of UXO offshore, and Daniel then concluded the German requirements for sand and gravel extraction concerning UXO. So thanks again to the speakers for their valuable contributions. We will circulate a link to speakers' presentations provided we have their consent, but I hope you understand that due to the sensitive nature of some of the content, we will be unable to share everything and may need to actually omit portions from this webinar recording. We will endeavour to respond to any questions not covered today, but if you do think of anything after the webinar that you want to ask our speakers, then please get in touch with us. We are keen to hear about your experience today, so we would be grateful if you could complete the survey that will be emailed to you shortly afterwards. Just a quick look to the future. MSAG are currently planning their next triennial conference, which looks set to be hosted in Hamburg, Germany, next June. We aim to host this as a hybrid conference, so you'll have the opportunity to attend in person or online, as you have done today. The main theme will be linked to environment and sustainability, and the event will actually span over 2 days. The first day will be the hybrid session, so there'll be presentations from industry reps from the marine aggregate sector, networking sessions, refreshments, and much more. And on the second day, this is to be confirmed, we look to be visiting the Fehmarnbelt tunnel construction site, which is an exciting development that's been going on for quite a while, of a tunnel system that connects Germany to Denmark. So more information will be available soon, so do keep an eye out for updates from CIRIA and MSAG on that. So yeah, that brings us to the close of today's webinar. So thank you for your time, and I hope you enjoy the rest of your day. So goodbye.